Okay, so you want to solve a quadratic inequality. Remember that in solving a quadratic inequality, we're looking to find an infinite solution set. Okay, so if we're going to find that infinite solution set, we have to find all the x values that make the inequality true. To do it algebraically, we follow a set of steps, and what we're really looking for is to try to get what we can come up with from a graph visually. If we look at a graph, we can figure out where the equation is above or below the x-axis by looking at it. But graphing takes a little bit more time than we might like to come up with some of these things, so we're looking for that algebraic approach. Okay, so there's a step 0 and there's a step 4 here. There are only 3 in class, but I want to be very specific about all of the particular things you do to come up with the equation and help you with your homework. So the step 0 is a somewhat obvious step in order to make this work, but we simply have to make sure that one side of the equation is 0, that we're evaluating with respect to 0, because we want to know if we're above or below the x-axis. And we start by finding all the critical points, which is done by finding the x-intercepts. We find the x-intercepts by taking the inequality and setting it equal to 0, solving. In this case, we factor into x minus 9 and x plus 2 being equal to 0. And so x minus 9 equals 0, or x equals 9. X plus 2 equals 0, which tells us that x equals minus 2. Those critical points are the only places where the inequality can change from positive to negative. These are the only values that can break us into intervals. And so when we build our number line, those are the only values that go on the number line. And again, I talked about in class, it doesn't matter how you choose to space those values. The only thing that matters is that we can clearly see the regions created. And this is region 1, and we have a region 2, and a region 3, created by the breakdown of minus 2 and 9 as the critical points. Well, if I want to evaluate a region, I just need one point out of that region. And I just need to know whether the height for that point is positive or negative. So start in region 1, we could take something like, let's let x equal minus 3. And if I do that, I take minus 3 and I plug it back in to the original. I'll say, okay, well, that's going to be minus 3 squared minus 7 times negative 3 minus 18, which is 9 plus 21 minus 18, or 12. Now, the actual number doesn't matter. It doesn't matter if it's 12. We could certainly use that if we wanted to graph it. But in this case, all that matters is that it's a positive height. And that tells us that is a positive interval. Okay, that's where if I plug in numbers, 2x squared minus 7x minus 18, I'd get out something that's positive. So if I move to region 2 has 0 in it. I should always test 0 if I can, because it's algebraically one of the easiest numbers to test. And it is very clear when we do that we get minus 18, and this is a negative region in 2. Then we move to region 3, and I got to test something bigger, so I'll test 10. And I've got 10 squared minus 70 minus 18, or 100 minus 88, which again is 12. And that therefore is going to be a positive region. That information, this number line right here, is the key to answering the problem. I want to know what x values cause x squared minus 7x minus 18 to be less than 0. And those x values appear, all the x values in region 2. That's not a great description of an answer. We'd rather use interval notation. I do not include the endpoints. Do not include minus 2 and 9, because we're strictly less than. So when I go to write the solution, I use an open parenthesis. I start from minus 2, I end at 9, and I close the parenthesis. And this is the solution that we're looking for. Hopefully you find this process pretty straightforward. It relies upon skills we've developed already and allows us to get to these answers pretty efficiently. It's also a nice break from graphing. So if you have any more questions, feel free to send them to me by email or post them on the Google Doc for today's homework.